Hey, Technostos, you've talked a lot about routing. Let's get into static routes and see a few different types of static routes that we could implement on our networks. In this video, we're going to get into what are some of the advantages and disadvantages of a static route. We'll get into what are some different types. There's 4 different types of static routes. And then we'll finish this off by talking about options when you're configuring the static route. In one of my videos, we were on the demo laptop and we were pinging this router right here. And what we had determined is that the packets would go out and this router knew of the network, so it could make it to this destination right here. But this router, when it tried to reply, was not aware of this network that this demo laptop was on. So it couldn't form any kind of packet to send back because it didn't know how to send it back to the demo laptop. And so let's talk about how we could actually implement static routes to do this. It would be really simple to go onto this device right here and create this static route for this VLAN 10 that says, hey, go this direction. This is your next hop. This layer 3 switch is your next hop if you're trying to get to VLAN 10, or if you're trying to get, to the 10.1.10.0 network. And so that is one of the advantages of a static route. It's very simple to implement. All I have to do is go onto this router and type in this simple command, and then it fixes the problems. Another thing is it's very efficient. There's no communication that has to happen. It doesn't need to talk to other devices. It just knows where it needs to send this data. So that's great as well. It uses up a lot less resources. It's also a lot of control in how I want things routed. If there is a mesh network and I want things routed a particular way, then it's real easy for me to just set up some static routes that it routes on that specific path. So there are a lot of advantages to static routes. However, there are some disadvantages as well. So some of the disadvantages of a static route is once you set it, then that's what it's going to use. And it won't automatically adjust to use other routes. And so because this isn't dynamic and it won't change dynamically, there's a lot of situations where we wouldn't want to use it. So we would want to use this if we have smaller networks, if we have something what's called a stub network, where we just have this simple network hanging off to the side, and there's no mesh network beyond that. That's called a stub network. And so those are the situations where we would want to use static routes. We also may want to use it for something like a default route, the default route that we're going to send things on. So yeah, there's a few different situations where we'd actually want to use static routes, and as our network grows and gets more complex and we create redundancy with our networks, then we probably want to switch more to a more dynamic routing protocol, so that way things can adjust as changes happen on our network. So let's go over a few different types of static routes that we would encounter. One of them is a standard route, one is a default route, one of them is a floating route, and then we have a summary route. So let's first of all tackle a standard route. A standard route would be one of, like I just gave an example for. This router right here needs to know how to reach the 10.1.10.0 network, so that way it can reach the different nodes that are on that network. And so we would enter in a static route destined for the 10.1.10.0 network, and it would be sending traffic to this layer 3 switch right here. So that would be an example of just a standard static route. So what is a default route? A default route is where you want to, if you can't find any other ways of sending this, any other networks that is inside the routing table, then use the default route. So an example of this would be this layer 3 switch. It would want to send out, if it's not connected to this directly connected network to any of its own VLANs, then it's going to want to send it to this router right here. And so we could set up a default route that just says, if you get anything and you need to send it on, just send it up to this router, to this interface right here. Another example is maybe router 2 here is connected to the internet and it needs to get out to the internet. So we would set up a default route that would point to the internet service provider. So then it would send any traffic that is not within its hierarchy here. It would just send out to the internet service provider. So another type is the summary route. So one example of this is down here, we've got the 10.1.10.0 network, we got the 10.1.20.0 network, and we got the 10.1.30.0 network. Really, just all of the 10.1.0.0 networks are going to be connected to layer 3. That's how we've defined it. So if it's a 10.1.0.0 network, then we want to send it this direction. That is a summary network. So even though not all of the, there's not a 10.1.11.0 network down here. But what we're going to do is we're going to create a summary route that just says, if you're trying to reach 10.1.0.0, go ahead and send it this direction to this router, and this router will send it in this direction because right here is all the 10.1.0.0. It will summarize it. It will put it all into one summary. So that is a summary network. And then we have a floating static route. A floating static route is the same as a regular standard route, but we put it in with a higher administrative distance. So it's not going to prefer that one. It's going to prefer the standard static route. And the reason why we would do that is because if something goes down and that route gets taken out of the routing table, then we have a backup route. So a floating route is essentially it's a backup route that it will be used if the other static route goes away. And one reason why it would go away is because the interface that it needs to send out goes down, and it would come out of the routing table, and then it would use another route. So that would be a floating static route. When we configure a static route on our routing table, we can either specify an IP address of the next hop, or we can specify the exit interface, or we could specify both. And there's advantages and disadvantages to each of these. So if we want to specify just that exit interface, that works out great, unless it's a shared network. If there are many, if this is an Ethernet network, and let's say this layer 3 switch, between layer 3 switch and this router is a shared network, but we have maybe multiple routers that are hanging off of here, it can't just know the exit interface, because then what is it sending it to? Is it sending to this layer 3 switch, or this router over here, or this router over here? So the exit interface works fine on point-to-point networks like HDLC and the point-to-point protocol networks like these, but it doesn't necessarily work in a shared network like Ethernet. Then we can specify the IP next hop, which works great in situations like when you're working with Ethernet. Then it knows where it needs to go. It knows that it needs to go to this layer 3 switch to get to the 10.1.10.0 network. But the problem with that is it then has to do a recursive lookup to see what exit interface it goes out of. And so it will actually have to take one more step, which could possibly be problematic with your hardware if you're low on resources at all. So therefore, it has to do extra lookup to find that exit interface. So that's one reason why I do like to configure, when I can, I like to configure both the exit interface and the IP address. And so then it knows what exit interface to go out of, and it knows the IP address that it needs to hit. All right, so there you have it, static routes. We talked about static routes, some of the pros and cons of them. We talked about types of routes, whether that is the standard route, the default route, the summary route, or a floating route. And then we talked about some configuration options, whether it's what is the next hop IP address, or what is the exit interface, or you could specify both the exit interface and the next hop IP address.